Hi everyone! After creating the car and making it able to move, in this episode I'm going to show you how to make the car steer when pressing left or right arrow keys in a realistic way. Let's start by adding new attributes to the car class. For the max steering, I have set that to pi divided by 30, which is equal to 6 degrees. In the main sketch file, let's now add few checks on pressed arrow keys like so. For the turn left method, we need to multiply the max steering value by the delta time, then subtract that value from the current steering angle. We also need to clamp the value between minus max steering and max steering. Same thing will be done for turning right, except that we need to add the delta angle to the previous steering angle this time. And for the rotate method, we're going to start with this version, which will just update both heading and steering angle for the moment. Obviously, in the real world, cars don't rotate related to their origin, and if we try to do so, cars will end up drifting in a non-natural way like this. So we need to find another way to rotate the car in an almost realistic way. So this is our car. To make this easier to understand, I'll display the car as a wireframe. Obviously, the car has an origin, which I'll present with a red dot over here. Now let's draw a few axes. Absolute axes are drawn in black, and the axes relative to the car are drawn in red. As you can see here, this is the car heading angle. All we need to do is to treat the car as if it is a bicycle. We imagine that the car has two wheels, one at the front in the middle to steer, and one at the back in the middle that cannot steer. Of course, these two wheels will be virtual, as we only use them for the physics. We can still render the other four wheels as we did in a previous video. The wheels are placed on an equal distance from the car origin. I'm defining the distance between the two wheels as the wheelbase. To start, we need to calculate the origin for these virtual wheels. The front wheel position will be equal to the car origin plus the car heading vector multiplied by the half of wheelbase. The back wheel's position will be equal to the car origin minus the car heading vector multiplied by the half of wheelbase. Now when we steer, we need to calculate the virtual wheel's new positions. Each wheel should move forward by a certain amount in the direction it is pointing. For the front wheel, we need to add the car steering vector multiplied by the velocity. And for the back wheel, we need to add the car heading vector multiplied by the velocity, because the back wheel doesn't steer. The new car position can be calculated by averaging the two new wheels' position. The new car heading can be found by calculating the angle of the line between the two new wheel positions. So if we translate all what we already said in code, the result will be the following. Last thing to do is to tweak the update method. So this is what the method contains on the previous video. Given that the rotate method is now taking care of updating the car's coordinates as well, we have to replace the line where we update the y coordinate with a call to the rotate method. Let's have a look at the result now. Much better. With this, we arrived at the end of today's episode. In the next video, I'll show you how to make the car interact with the track. Thank you for watching and see you next time.